Welcome. In this video I'm going to show you how you can perform a one sample trinomial test using R. I'm using Jupyter Notebook, but the R code should also work in RStudio. I'm using R version 4.3. Now this test is a test for a hypothesized median, which makes it an alternative for a one sample Wilcoxon signed rank test or a one sample sign test. The big difference here is that it does not exclude the scores that are tied with the hypothesized median. To show you how this test can be done, I'll need some example data. So I'm using student statistics data file. It has some responses from students on some questions. I don't need all the data, I just need one ordinal field, so I'm going to be selecting teach motivate as my ordinal field. Using the table function, I can then give you a quick impression, and you can see that, for example, 7 students agreed with that they felt motivated by the teacher. Note that these are not in a correct order, so let's also store the proper order as a separate vector using coding, or actually not using coding, storing it as coding in a vector. Now I have a separate library that I made that simply has a function that can do this test, but in this video I'll show you how it can be done without using that library. So the first thing I then need to do is I need to remove any missing values, so I'm going to use na omit, and then I'm also can quickly see how many cases there actually were, so the sample size of n, and I think it was 54. Now we also need to replace everything with numeric values, so we can use as numeric and loop over all the codes that we have, and that should give us the ordinal field but then as numbers. So if I now do print ord field num, I should actually only get to see numbers. Set a hypothesized median of, let's say, 3, and we can get started. The first thing we need is the number of positive differences negative from the hypothesized median, and also actually the number of ties, so with the hypothesized medians, which can simply be done by checking this. This will then actually create booleans, true or false, and if it's true it's a 1, so we can sum those up, and that gives us those 3 values. I'm gonna store these as a separate vector, and again the sample size should be the sum of those 3, and that should give me the 13 were above the hypothesized median, 29 were below, and 12 were equal. Now the expected proportions for the number of ties, we're simply going to use the sample proportion, so that's going to be the number of ties in the sample divided by the total sample size. And the rest we actually distribute evenly over the other 2 categories. So we calculate the expected proportions of number of ties, then whatever remains, so 1 minus that, we divide by 2, and the other one is set then equal to that one. So that gives us the expected proportions. Then we can use the multinomial probability mass function, and since we only have 3 values, it's going to be a trinomial distribution, and that then eventually boils down to this little function you see over here. Now as you can see here, it's still referring to Python, but actually we simply need the factorial function, which comes by default in R. So I don't need all of this, we need the factorial. And we can just fill out all those values because we have all of them. This means to take the expected proportion actually to the power of n. It's still showing the sample proportion, but actually these should be the expected proportions. That goes for all the formulas. This is therefore a big calculation, but everything we need is available. But that's just the probability for this specific sample, and we want as our sample or even more. So the formula for that looks like this. It's 2 times, and then we have the sum of starting with the difference between the number of positives and the number of negatives. So we call that ND. So that's what's being done over here. And we need to sum starting from there all the way to the sample size, so that's being done over here. Then we go from 0 all the way up to, and then this is the floor function, so basically it rounds down. So we can use this, and that's being then covering all of these. And then we simply fill out that formula we used earlier again, but now we use j, which is then this one, j plus I, so that's this one plus that one, and then whatever remains as our third one. So that's what's being set up over here, and then this is just using that whole function that we had earlier over here, but now with the different values for the frequencies. We keep on adding those up, and in the end there was this 2 times, so we multiply it by 2, and we finally have our p-value, or significance as SPSS calls it. If this value is below 0.05, we would usually then reject the null hypothesis. In this case, we would therefore say that there's a significant difference with the hypothesized median in the population, so it will most likely not be that 3. Alright, and that's it. I hope this video was helpful, and thank you for watching.